Okay, so what we want to do now is we want to go one step further. We want to introduce today biofuels. However, if you looked at the previous video that we did, we talked about fossil fuels, but I didn't actually talk about fossil fuels being non-renewable. And that's one of the big issues with fossil fuels. Once we burn the crude oil that we've just taken out of the ground, it's gone. It's gone into the atmosphere. And where has it gone? Well, it's produced carbon dioxide, okay, and that carbon dioxide contributes to greenhouse gases. And not that you wouldn't have been aware of this, but obviously burning the fossil fuels, whether it's natural gas, whether it's coal, or whether it's petroleum, all those lead to the greatest anthropogenic man-made source to carbon dioxide levels and global warming. Since obviously we've been doing that, which has been a long time. So when we burn carbon, you can see that it is a one-way process. So it's just going in one direction. So the carbon dioxide ends up in the atmosphere. Now, I wanted to contrast that with a biofuel. So what I've actually done here is, if you can follow through the equations, and all these equations you can sort of work out for yourself, maybe a little bit later. So I'm looking at bioethanol. So bioethanol is a biofuel. Biofuels, by the way, not that we've even talked about them yet, but biofuels come from living or recently living plants or animals. So it could be an animal or a plant that's composting, for example, but essentially we can use those plants or animals, mainly plants, okay, rarely animals, but mainly plants. So we can use those plants to generate biofuels. And the two sorts of fuels that we have to look at are bioethanol and biodiesel, but I'll come back to those in a minute as well. Alright, so here it is. So what happens is, this occurs in our plant, obviously, whatever we are growing. In the case of the bioethanol, the plant will be sugarcane. Alright, so the carbon dioxide and the water are being used in the sugarcane to produce glucose, funny enough, sugar, okay. The plant uses that to grow and obviously metabolise. What we do then is we actually cut down the sugarcane, depending on whether it is used as a fuel or for consumption. And there is a debate on that we'll talk about in a minute. So are we growing sugarcane for sugar? Are we growing sugarcane for fuel? If you look it up, for example, Brazil have been growing sugarcane for fuel now for, I think, a couple of decades in order to extend their fossil fuel reserves. But again, we'll talk about that in a minute. We'll talk about why we're even looking at biofuels. So, plant produces for us the carbohydrate. The carbohydrate ends up in the plant. What we then do is we extract from the plant the carbohydrate that we're after, and so in this case here, it would be sugar. We crush the sugarcane on a large scale. The sugarcane is then exposed to yeast, and we may have talked about this in Year 11. So yeast fermentation occurs on a large scale in an industrial process. That produces for us ethanol. Now, this is where the bioethanol comes in. Bio because the source of ethanol is obviously a biological, it's a plant. And we get some carbon dioxide produced because we can't avoid that because that is what's produced from fermentation anyway. What we do now though is we take the bioethanol that we produced and now we run it as a fuel. So here is the bioethanol fuel. It's in a car perhaps or some sort of a motor. We're burning it, or we could even be just using it to generate heat, maybe for heating purposes. So we're burning the fuel, we get carbon dioxide again, and we get water, okay, as a byproduct. However, here is the difference between how a biofuel works and how a fossil fuel works. Now, a fossil fuel, if you look at that equation, there's only one equation for combustion, and CO2 goes into the atmosphere. There's no other way I'm taking that carbon dioxide from the atmosphere and making more plant material. That did happen, but it happened like millions of years ago. So I can't simulate a million years of aging under the ground in 12 months, whatever the fuel is when I need to produce it. Can't happen. But I can do it if I've got plants. So what happens is the carbon dioxide that I produce from burning the fuel goes back into the atmosphere. Provided I've got enough plants, and here's the key, provided I've got enough plants, in this case sugarcane, to absorb the quantity of carbon dioxide that I'm putting out to produce the glucose, the carbohydrate, that I'm going to extract from the plant again, provided that is proportional, then hopefully you can see that this becomes a continuous cycle in theory. So the carbon dioxide that I produce is absorbed by the plant. The plant uses the CO2 to produce the sugar. I use the sugar to produce ethanol. I burn the ethanol, I make CO2. CO2, plant takes up CO2, produces more ethanol. So it becomes a sustainable process. And the key is biofuels are obviously renewable. So we can actually cycle this, recycle, okay? I guess what we're doing is recycling carbon dioxide, which is the waste product. So we're taking carbon dioxide, but we're using the plants to our advantage. So that's really the basis of how biofuels work. We could actually use, and the government a few years ago tried to introduce something called carbon tax. And carbon tax was really to do with, are you operating under a fossil fuel type scenario? Are you just pumping CO2 into the atmosphere? Or have you got some process in your industrial process where you're reducing your carbon emissions? So if you were using biofuel, for example, if you were using more biofuel than fossil fuel, then in theory you'd be charged less tax because you were based tax on how much CO2 were you putting into the atmosphere, how dirty was your industrial process, is how the government was going to try and work that. Hasn't quite come off as much as what we would have liked, unfortunately. So the biggest polluters would have been those that would be the taxed the most. There is some tax associated with that, and that goes back into, obviously, research and how can we improve this whole process of reducing emissions into the atmosphere. And we've talked about that in the environmental section. Okay, biofuels. So why are we looking at biofuels? Well, I just said number one is that they are renewable. Number 2 and 3, extend fossil fuel reserves. So that's been around for a while. So we know that there is a use-by date for fossil fuels. So eventually they will run out. When I was a boy, a long time ago, the theory back then, I think it was 2050, I think was the number given to the point, based on demand, when all fossil fuels would be exhausted, that's it. But now we've got fracking basically in the equation, which means we can extract fuels where we couldn't extract fossil fuels before. And that's got some positives and negatives, as you would be aware of. So we've got basically the whole idea that we can extend our reserves if we mix existing fuel with biofuel, and you can do that right now. Some service stations will offer E10 or E95 fuel. E95 is 95% ethanol. Not many cars can run that, by the way. E10 is the most common one. And I think there's also an E85, okay, from memory. And you can run your car with a blend of ethanol and petrol mixed together, octane mixed together, only if it is compatible. The only drawback to that is that old cars can't use it because the fuel system wasn't designed to run ethanol. Ethanol degrades the fuel system. The parts in the fuel system, they used rubber back then, not silicon type based products. Anyway, that's another question, another discussion later. The other thing is biodiesel. So already we've actually got biodiesel that's available. However, if you do your research, I think there's one outlet in South Australia only, at Cavan. And although biodiesel is good for the environment because it's sustainable, we unfortunately can't run it in modern diesel engines. There's a whole other discussion about diesel as well. So the first thing is extend fossil fuel reserves, and we can see that already with the blended fuels and with biodiesel. And obviously it reduces environmental impact. So if we've got a fuel that is renewable, that takes CO2 out of the atmosphere, and we're looking at global warming in theory, if we were all to take on a biofuel, would go down. However, unfortunately, there's always that negative to all the stories that we look at. Back to biofuels, we just spoke about bioethanol. Biodiesel I forgot to mention, but that comes from palm oil. And you might see trucks around Adelaide is also going to fish and chip shops collecting the used oils. They have to be a plant-based oil, not a mineral-based, so not a fossil fuel oil. But if I take plant-based oils, like sunflower oil or something like that, then I can actually use a process called transesterification, and I can make from that biodiesel. It's almost the same as normal diesel, but it is a little bit dirtier in terms of the byproducts that's in it. But that's an issue that people are addressing right now. The advantages and disadvantages. So biofuels in general, the advantage, greenhouse gases are reduced, so we get less greenhouse gases, okay? The other issue over here, all right, the problem with this though, is that in order to produce the biofuel, we have to grow crops. Crops use tractors and machinery and transport, and 99% of the time, the stuff that we're using to grow the crop probably runs on fossil fuel. So we're using fossil fuel to make a biofuel, so we may be increasing CO2 levels. I think we're doing a good job, but in reality we're not. Less CO2 in the atmosphere, and there is the issue, okay, so there is an advantage. So we're growing crops for food, or we're growing crops for fuel, and that may impact the cost of food crops as well. They may go up because we're using more of our cropping land to produce fuel-based crops. So there's a discussion on that as well. So not always positive for anyone that we look at. The waste from landfill. So I don't know whether you know that you can take all your organic waste to recycle stations, and it normally goes to landfill. However, they can use the waste, all right, to produce biofuels, but that requires water. Water is precious. The other thing in relation to this is that if we do say, all right, we need, if biodiesel becomes the number one fuel, which is unlikely, but if it was, then the demand in palm oil that comes from palm plants grows up, or increases, I should say. Also, it does grow as it increases. But that means that the demand increases, so that means people are not going to necessarily, in developing countries, they're not going to put there's enough palms in the ground compared to what they're taking out of the ground to produce the biodiesel. So there is a balance. So if I'm obviously cutting down a forest to produce palm oil, I need to be putting it back, and that's also part of the deal. So it's not hard to work out that if I'm only growing sugarcane to produce ethanol, but I'm not planting any more sugarcane, the CO2 levels are not going to go down, okay? They're going to continue to increase because I haven't got the sugarcane to take the CO2 out of the atmosphere. So if anything, we should be increasing the level of vegetation to compensate for that. And some of you might be doing that as part of your sheet task anyway. So that's really just an introduction to biofuels. Then on the end of that, I just want to take on, you can do this by yourself, but we also look at other forms of energy, solar energy and wind energy. South Australia is pretty much up with wind energy. You'll know that wind energy, how it works. You'll need to look at the advantage and disadvantage of wind energy. I'm going to ask you to do that in your textbook. For us, it's on 373, 372, not too difficult to look at that. Solar energy, so what is a solar panel? How does a solar panel work? It's not too complicated. I think you can do that by yourself. What are the advantages and what are the disadvantages? Obviously wind, it only works when it's wind, okay? And the issue with wind energy is where and how do you store it? And then we talk about batteries a little bit later because it's great having the energy, but it's energy that you use immediately. The same thing with solar energy. There's batteries become more affordable. It's obviously only generated during the daytime and depending on how much light we're getting, but that goes back into the grid, compensates for what you are using, we're pulling out of the grid, but it doesn't happen overnight. So if you've got solar energy, you want to do all your washing and everything else during the course of the day, not at night. So those two things, you would need to just look at those two things, look at the advantages, disadvantages, and learn out basically how they work. But that's all you need to do. Again, it's just a little bit like I said it initially. So a lot of this stuff is like it's factual. So you just got to sit down and actually learn it. And I'm giving you the bare minimum, the skeleton of what you should be doing. Okay, but that's our quick lesson on biofuels, and we're going to follow that up with a bit more detail about the bioethanol and the biodiesel shortly.